Hello everyone. Today we are going to delve into some interesting geometry configuration. Here you have a bigger circle and a chord BC of the circle. The center of the circle is O. You have another smaller circle which is tangent internally to the bigger circle and also tangent to the chord BC at P. Now it's tangent to the bigger circle at T. Now you have to show that if you extend TP, it passes through the midpoint of the arc BC, not containing the point T, which is shown by the point M, needs to be proved to be the midpoint of the arc BC. This can be equivalently proved by BM equals CM. Let's try to do that with some angle chasing and tangencies. Let's get started. Here is the configuration that we are thinking about. First, let the center of smaller circle be O1. Let's prove that points T, O1 and O are collinear. Notice that the tangent at T to any one of these circles will also be tangent to the other circle. Thus, assume that it is drawn tangent to both these circles and let's call the line BL, the tangent line. Now, O1T will be perpendicular to L. Similarly, OT will also be perpendicular to L because it's the angle made by radius and the tangent, which will always be 90. Since TO1 and TO both are perpendicular to L and both lie on the same side of the line L, it turns out that T, O1, O are collinear. This just follows from the same angle criteria. Alright. Now thus we have proved points T, O1, O are collinear. Let's join O1T. Let TP intersect the bigger circle at M and let's join OM. Now you are going to witness a magic. Let's prove that O1P is parallel to OM. First, let angle PT O1 be equal to theta. So this angle will be theta. Alright, since that angle is theta and TO1 and PO1 are radii of the smaller circle, angle O1PT will also be theta because it is isosceles triangle. Alright, consider the larger triangle TOM. It will also be isosceles, right? Because EO and MO are radii of the bigger circle. Thus, angle OMT will also be theta. Notice that angle made by the transversal TM with the lines O1P and OM are equal, making them parallel. So it is just the corresponding angles are equal, implies the lines are parallel. So thus we get O1P is parallel to OM. Great. What is the consequence of it? Well, the ideas one could derive from the radii being parallel are that their corresponding tangents are parallel because they are perpendicular to those two parallel lines. Now, since these two parallel lines become perpendicular, they will be parallel. Thus, the tangent at P, which is BC, will be parallel to the tangent at M to the bigger circle because the corresponding radii are parallel. Well, let's now erase these segments we now have the tangent at M to the bigger circle. And it is parallel to the chord BC. So, intuitively, you might get a reason why M is the midpoint of arc BC, not containing T. So, you could see that in any circle, if a chord is parallel to a tangent at some point on the circle, then it must be the midpoint by symmetry. Now, we are going to take forward the argument in a rigorous way. Suppose you join OM. And you join BM. And you join CM. Let's actually join BM at first, then let's join CM. Notice that angle made by OM and the tangent at M, say L prime, is 90 degrees. And let's call this angle to be alpha. That is the angle made by the chord BM with the line, tangent line L prime. So this angle will be 90 minus alpha, a simple angle chase. Now extend MO beyond O to intersect the chord BC. Since we derived that L prime and BC are parallel, this will also be 90. Alright, so if it's 90 minus alpha and 90 degrees, the angle at B, which is MBC, would then be alpha. Just sum of angles of a triangle is 180, will imply that angle MBC is alpha. Thus, we derive that angle NBC equals the angle BM, and let's call this point to be some K, BMK. This implies that, let's go in the other way. This angle will also be 90 minus alpha. So, which is because the perpendicular from the center of the circle bisects the chord BC. That means we have this length equals this length. Maybe let's call the midpoint to be S. We have BS equals CS. Thus, the angle at the other side, CMS, will also be 90 minus alpha because the triangles are congruent. By angle 90 degree being common and the sides BS and CS are equal and MS is common. So by SAS criterion, the triangles are congruent and you get that this angle is also alpha. Thus, we get that triangle BCM is isosceles. So by a simple angle chase, we proved that the perpendicular from the center to the chord BC also passes through M, making the triangle BMC isosceles, which imply BM equals CM. You may also arrive at the conclusion of isosceles triangle BMC by tangent chord theorem if you are aware of it. Since this angle is alpha, the angle made by BM with the tangent, which is alpha, equals angle made by the chord BM on the other side of the circumference of the circle. If you consider any point on that circumference, then the BM chord will subtend alpha at that point. And thus, you can get that BM equals CM, because we know that angle MBC is alpha already. So now this proves that the arc BM equals the arc CM. This is because equal chords subtend equal angle at the center, and thus the arc length will also be equal. And hence we have proved that the line TP passes through the midpoint of arc BC. One may also tackle this problem using homotopy, because since the circles here are tangent, their centers are collinear as we proved. So if you sort of dilate the smaller circle to the larger circle, it will take the center O1 to capital O, and the smaller circle maps to the larger circle, and point P goes to the point M. And thus the tangent at the point P must be parallel to the tangent at point M, because the angles are preserved in homotopy. So you cannot tilt the tangents with respect to the line TP. Thus it will be parallel, making it again the midpoint of arc BC. So here is an interesting configuration in which you can see the point of tangencies concur at the midpoint of the arc BC, not containing the points TIs. So this looks amazing in GeoGebra. So go ahead and plot yourself and check it out. We will discuss more configurations like this in the upcoming videos. See you all then. Thank you. Bye.